Okay, we did not return to number one, which I left off the recording yesterday because I started it late, so I'm returning to number one now, if that's helpful. Number one on the test, it says, it gives you a picture of a graph. It also gives you the equations of the graphs involved, and it says, what is the area of the shaded region shown? And it's a shaded region trapped between two curves, and it's really, really darkly colored. And it's kind of hard to tell which equation goes with what, so I'm going to give you a little reminder about how some equations are put together. The difference, which I showed yesterday, the difference between y equals x squared and y equals x to the fourth, they both start in the same place. They both open upward. X squared looks like this and crosses the point 1, 1 and negative 1, 1. And the other one does too, because if you put 1 in for x in either case, you're going to get a y kicked out of 1. So both of them have that point. But the x to the fourth one is a little flatter on the bottom for a little longer, like this. It still starts with a vertex here, and it still only encounters the x-axis in one place. But it comes out like this before it heads up. I mean, this is really an exaggeration, but that's the difference between those two types. So if it's difficult for you to tell on the test which equation is which, one of them's going to have a flatter bottom than the other, and it's the higher power. So there you go. And it's also, I also mentioned this, it's extremely clear, very, very visibly clear where they cross each other. So the limits of integration should not be difficult to come up with. What? Did somebody say What'd you say?
Just do the right minus the left, right? Or is it going to be
Top minus bottom. They'll have a right minus left opportunity later.
Oh, that's when it's x equals.
Okay, so yesterday we finished up with number 10, which was lifting slabs out of a cylindrical tank. Same thing on here, it'll be a cylindrical tank. It'll just have different dimensions than I gave you, and it'll have a different fluid in it. But the weight density will be given. So if you understood how to do that one, it shouldn't be too bad. Number 11 is a bonus problem, and it has to do with the surface area. And I think on the actual review page, it tells you where to find that formula if you want to learn how to use it. Doesn't it? For number 11? Okay. It says find the area of a surface generated by revolving the curve y equals something with an x in it about the x-axis. You're going to find the surface area of that. And then number 12 and 13 both are referencing arc length. In number 12, it gives you an equation between a certain set of x's, like from 2 to 6 or something. And it says, what's the length of this curve from 2 to 6? And 13 says, and 13 is multiple choice, says, find the length of the non-smooth curve y equals, it's got an x in it, in a certain range of values. And it says, round your answer to the nearest thousandth. And so it's multiple choice, and all answers are rounded to the nearest thousandth. And they are not really very different from each other, the answers. You'll have to get the right one to choose the right one, I think, because they're pretty close. Okay, so those are the bonus questions. And then there's 2 more required, and that's 14 and 15. Neither of which is very hard because we spent so much time practicing the force on a plate submerged in a liquid. That's what number 14 is. And it will, again, either be an equilateral triangle, a semicircle, or a rectangle. Now, I think that is on the chapter. Well, it's on the Quiz B review. And so if anybody wants me to forward that to you, I've already got those, all 4 of those demonstrated already on a video. I'm happy to do one if you want, just to bring it back to memory, but you're going to have to tell me what shape you want to do, and we can do one if you like. And if not, then I'll just go on to 15. You want the equilateral triangle?
Yeah.
Okay. Okay, so you're going to have a tank of some kind like this, and the surface of the fluid is going to be up here. We'll say that it is seawater at 64 pounds per cubic foot. That's the weight density. And 10, we are going to take an equilateral triangle and we are going to shove it into this liquid until one of its sides is level with the surface. So it's going to look like this. And it will be equilateral. Okay, so we got to figure out the force on this. And force, if you'll remember, force is, anybody? In this scenario, force is pressure times pressure times area of the strip, of a strip, which we have yet to draw. Okay, because each strip of this has different pressure on it depending on the depth. Okay, and that comes back to breaking it down even further. What is pressure?
Weight density.
Weight density times depth times the area of the strip. And every strip has a different force on it, and so our integral will magically collect all our forces if we can just come up with something to put in for each of those things. Now the weight density is obvious, it's 64. Y is obvious, and in this case, in these scenarios, we number the axis from 0, where there's 0 pressure, down to the very bottom, wherever that is, and I'll just say it's from 0 to, it doesn't really matter how deep this is, what matters is how deep that is. And so we'll come up with that in just a minute, but that's what, we're going to have 0 be here, and then we're going to have the Y value, whatever this turns out to be there. I haven't given you the dimensions yet. So the Y isn't really that big of an issue either. The weight density is going to be given to you. Y is how deep it is. If we organize this thing to go deep from the surface area, which is 0 down this deep, then it's just the strip, whatever we draw, is just going to be Y deep. So that's already there. Even the width of the strip is already handed to you. It's dy. It's the dang length. That's the killer, right? So I better give you something on this. Let's say it's an equilateral triangle of length 10. 10, let's keep it in feet so that we don't have any reconciling units here. So I'm going to start to build the total force integral. Force is a collection of, the total force, total, is a collection of little forces from where to where? 0 to 5 or 3. How many of you are questioning that and going, what? How'd they come up with that? Anybody questioning that?
I know how you came up with it. I know what the idea is, but I can't remember the equation type of thing for it.
When you take an equilateral triangle and you draw from a vertex to the opposite side in such a way that you bisect this angle or bisect this side or perpendicular, all three things happen if you do it right. If you draw an altitude, you get perpendicular, cut the side in half, and you cut the angle in half, making these 30, 60, 90s. So this is 5 because it got cut in half. Since it's a 30, 60, 90, this is 5 or 3. Everybody see it? You all right? So that's our integral. That's what this is right here. It's 5 or 3 deep.
Is it always going to be 1/2? Base being whatever.
If it's an equilateral triangle, anytime you drop an altitude in an equilateral triangle, 3 things happen. It cuts the angle in half that it comes from, it cuts the side in half that it hits, and it's perpendicular, creating 2 congruent triangles that are 30, 60, 90s. Do you understand that whole mouthful? Okay. So we're down to 5 or 3, and we have our, I'm going to back this off a little bit so I can put some constants out here. It's going to be 64. That's my weight density right there. Y is going to have to stay in here because it's a variable. The area of the strip is going to be length times width, and I know the width will be dy. Here's my strip right here. There's a representative strip. It doesn't have to be right in the middle. It kind of looks like it is, but it doesn't have to be. It's any strip collected from 0 to 5 or 3. And its thickness is dy, so I have absolutely everything I need. It is also y deep. That's this y right here. So weight density times depth times the area of the strip. And I have everything I need except for the length of the dang thing. And that's the hard part. That's the part where you get the points if you're correct. I already called Terry. She said that she would take care of your attendance, whatever. You can take that note to your teacher so they know we've been. Okay? All right. You bet. find the length of that strip. And not only do I have to find the length of it, I have to find the length in terms of y. So that everything in here that I'm integrating is in terms of y.
That's the equation for that line right there.
Which one? This one or this one?
Doesn't really matter, but for sure. the one-
Okay. Gonna do the one on the left?
Sure,
The one on the left.
sure.
Okay. So he's saying, what Kyle's saying is that we need to find an equation of this. But in order to do that, we've got to figure out where we want to put the origin.
Just right at the bottom.
Right here?
Yep.
Okay. So we'll superimpose a grid on this so that we can get an equation. And you want to put the vertex, the vertex of this right at the origin like that.
Yep.
Okay, good. That's probably a really good choice. That way you don't have a y-intercept other than 0. 0's a nice thing. So I'm- Okay, yeah, I'm writing an equation for the line. That's why I'm putting it in red. Y equals what? Rise is 5 root 3.
Yep.
Run is negative root 5.
Yes. I mean.
What's that? Would that work?
Yeah. And then X, yeah.
Not, I mean, I can't plug that into the integral yet because it's y equals something with an x in it.
We'll flop it around.
Okay, flop it around. Minus 5 over 5 root 3 is equal to, or y is equal to x. Before I put it in there, I'd like to do a little cleaning up if that's okay. I mean, I could have done it right here. I probably should have. Take that 5 out and I have root 3 over 1. Here I've got 1 over root 3, which needs rationalizing, but your calculator doesn't care. So I don't care if you put this in the integral as negative 1 over root 3y. I don't care. It's fine. And the reason why this works, I'm going to go ahead and clean it up here a little bit. It's negative 1 over root 3. You may leave it like that because your calculator doesn't care, nor should your future professors, but they do. Thank goodness they're not getting a videotape in this. Okay. Recording. Okay, so this is x in terms of y. And what we have here, folks, is this value from here to here. That's the x value on that red line, depending on how deep it is. And that's what I need. That's the x value right there. That's x. And I need 2 of them. Is it going to matter that it's negative?
No.
Yes.
It'll have a negative x value. You probably should just make this positive because it would be the exact same thing over here. That way you can dodge that bullet if you want. You know what I mean? Kyle told me to get the equation of this one, which will work, but your x will be negative because you got to go left. That'll probably affect your integral. We really just want the length of that, and lengths are always positive. You okay with that? So I'm going to change that sign because I'm looking for a length. It's the same on the other side, and I'm going to need 2 of these to get the width of the strip because this is only one of them. Do you agree? So the thing that I'm going to put inside here, inside the integral, is going to be 2 over root 3 y. Did you catch all that? You want me to do it again? I can. I can show you in detail what happened there, but I did a lot of it in my head. You need to see more detail? Yeah? Okay. So let me take this off. This is where we were. And I've got to put something right there, and it is the length of the strip, which is 2 times x. See it? I need 2 of these. That's the 2 over the root 3 to get the length of that strip. So this is the weight density. This is the depth. This is the area of the strip. All of this right here. Integral-wise speaking, I can take the constant out. So what I end up with is 128, if you will, 128 over root 3. That's taking the 64 times 2 over root 3. You with me? Times the integral from 0 to 5 root 3. And what's left in here is a y, which was the depth, and a y, which was part of the length. Turns out to be a pretty nice little integral. Takes a while to come up with. Okay, so the moral of this story is whatever the shape is here, you need an equation that will give you an x value. You may have to write the equation the way you're comfortable with and then solve it for X in terms of Y, because you need that X value to double to get the length of the strip, regardless of the shape. You need an equation. So if it's a semicircle, you're gonna need the equation of the circle.
I don't know how you got 48.
So will it only ever be an equilateral triangle for the depth problem?
Pardon me?
For the pressure problem, will it only be equilateral triangle?
No, I said it will either be an equilateral triangle, a semicircle, or a rectangle.
No, I mean, if it is a triangle.
Yes,
will it be-
if it is a triangle, it will be an equilateral one, and it will be point down. Doesn't matter if it's point up. Well, yes, it does. It matters if it's point up, but it won't be. It'll be point down. Okay, so what do we get for an integral? Anybody get it?
16,000.
16,000 what?
Exactly, nothing. Pounds per foot.
Just pounds. Just pounds. Force is measured in pounds, work is measured in foot pounds. So this is not foot pounds, we're collecting forces, total force. And by the way, unless you're sliding this thing right along the very, very back edge or front edge of the glass, that force is actually applied to both sides. So if you were to give me double that, I'd still give you full credit, or if you just give me the single one, I'll give you full credit, because that's neither here nor there. It'll be very clear in the question if you're asked this again later. It'll be easy thing to fix. So if you're being really, really, really true to it, probably you would double it, but you don't have to. Single's fine, I'll give you full credit. No problem. Okay, are you ready to move on?
Yep.
Last question, number 15, has 3 parts. None of them are multiple choice. However, 2 of them are extremely easy, and the other one is too, if you understand what's going on. Here's what it says, something like this anyway. For a certain species of rodent, the mean weight of an adult is 1.8 pounds. Could be talking squirrels here, maybe gophers, I don't know.
Oh, I thought we were talking about humans, and I was like, that's not.
For a certain species of rodent,
Okay.
the mean weight adult is, we'll say 1.8 pounds. With a standard deviation of 0.3 pounds. You already got the details? I'll put some of these things on the board. I'll get rid of this so we can talk about this question and people can see it.
The average is what? What is she? 1.8,
These are the actual variables that they use. You don't get to see them very often, especially in your calculator. They just put it in the way it is, but it's mu. That's mean. And the mean is 1.8 pounds. And the standard deviation is small cursive S. It looks like an O, small cursive O, the Greek letter S, like that. Standard deviation is what did I say, 0.3?
Yeah.
0.3 pounds. Okay, so here are the types of questions with that information, and that's all you get. Mean, standard deviation is all you need. And then they will ask you specific questions dealing with the normal distribution in your calculator, right? They couldn't sure have to memorize Gauss's and formulas. But it's still area under a curve, that's why it's in a calculus book. Still area under a normal curve. You just don't have to have the formula, because your calculator does. You just have to do the figure. Okay, so the A part would be something like this. What percentage of these adult rodents have a weight that is more than 2 pounds? So do you remember how to do that? E is percent of the whole population that is more than 2 pounds. So in your calculator, you go to distribution, normal CDF, CDF, and then you put in, depending on the operating system of your calculator, you put in 4 things. If you have a newer, actually an older operating thing, then after this pulls up on your calculator, you'll have normal CDF. Does anybody have this, or is this just me? CDF parenthesis. Anybody have that? No?
That's what happens after you say next.
Nobody has this? Okay. Then I don't need to do this part then. So after normal CDF, you fill in the details of the screen that pops up. Okay, so on your screen, if it's got what hers has, you need a lower, it says lower upper, that would be 2 and something pretty big. She has 100, which is certainly going to take care of anything in the tail. That's fine. As long as you go up about 5, 6, or 7 standard deviations high, that should gather enough information to do it. The recommendation from the people who teach this say that the upper bound should be 99999. They usually use 5 numbers. That would certainly take care of it. Okay, but Rachel's got 100, which is way more than a couple of standard deviations up. So this will work great. And then it says mute. Actually has a mute, but 1.8, sigma is 0.3. And then there's the word paste. Is that what you go to make it execute? Okay. All right, so hit paste. And what do you get for this? 45? 25.
25.
So 1 in 4 is obese.
So about 25% of them are this way, okay? Or above, or more than 2 pounds, okay? B part says, what percentage of these adult rodents have a weight between 1.5 and 1.9?
What was it? 1.1?
47%?
Yeah.
Okay, now this last part, I do not understand why kids at your level of mathematics have trouble with this. And most of them don't, but some people do. And you don't have to admit it if you have trouble with this, but learn it so that you don't. The last question says, and I would hate to be the one to gather them all up if they truly are rodents, but in a group of 183 of these rodents, how many of them, this has to do with the percentage, but it's not a percentage question. How many of them will weigh less than 1.5 pounds? No, I don't want 1.5, 1.2. How many in a group of, how many did I say? Group of 183 of these adult rodents. How many of that 183 will weigh less than 1.2 will weigh less than 1.2 pounds?
You can't put 1/6 of a rodent.
I will take 1/6 of a rat.
You should have a whole number, round it either way, and I'll give you credit either way. I don't care whether you truncate or round it. Sometimes it's the same thing, sometimes it isn't. I don't care. But give me a whole rodent, please. Whole number of rodents.
4 to 5.
And-
But closer to 4 than 5.
So do you know how to make this calculation? You first of all find out the percentage that are less than 1.2 by putting a minimum of maybe negative or maybe 0, or I even go less than that, maybe negative 10 for your minimum, a maximum of 1.2. Find the percentage and take that decimal times 183. Some people have the hardest time making that last thing. Should not be happening at your level of math.
You never wrote it less than 0.
Because it's on the normal curve is on a continuum and the tail goes forever left. So it doesn't care. Doing the math doesn't have to make sense. But if you use negative 10 for your lower bound, it's definitely going to get all the area, all the counts anyway, on that tail that's asymptotic to it. I'm just saying you need to go several percentages. Not just one. How many people? 4? Only 4?
Yes.
Okay.
I don't know. I
Only
just think
4.
that it could be got like
Something could
2%
be
chance.
that's at 2%.
Okay. All right. That's what you're up against on the last question, and that's it. Test will be tomorrow. Okay. Shall I just send you all the link again, and then you can throw it out if you don't want it?
Yeah.
When you're done with it, throw it away too, please. I don't want it floating around out there on the internet. Use it for what you need it, and then
I'm gonna make my
Get rid of
YouTube channel.
okay. Call me with any questions.
Of you going.